Okay, this is the P2 paper from June 2024. It's question number 9, and this is an integration question. We're going to be working out definite integrals to find the area between curves and lines. We're also going to be having a look at stationary points, which will involve a little bit of differentiation. So let's have a look at the question. It says figure 1 is a sketch of the curve with this rather strange equation here. And it says point P is the stationary point of C. Can we find the x coordinate of P? Well, yeah, certainly. The rest of it might be quite complicated, but that is certainly something we should be able to do relatively quickly. So we've got A, we've got that this curve is y equals 2x to the power of 3 over 2, 4 minus x there. So if I multiply that out, I'm going to get y equals 8x to the power of 3 over 2 minus 2x to the power of 5 over 2. And if I want to find stationary points, I'm going to differentiate and put equal to 0. Let's do that. dy by dx then. Multiply by the power, take 1 off the power. 3 over 2 multiplied by 8 actually gives me 12x. And taking 1 away from 3 over 2 is a half. Minus, multiply by the power again, 5x. Taking 1 off the power gives me to the 3 over 2, and let's tell the examiner what we're doing. At stationary points, we know that dy by dx is equal to 0. So dy by dx is equal to 0, which means then that my expression 12x to the half minus 5x to the 3 over 2 is going to be equal to 0. Let's take x to the half out as a factor, which will leave me 12 minus 5x equals 0. So I either get x to the half equals 0, which will give me x equals 0, or I get 5x equal to 12, x is equal to 2.4. If we just quickly go back to the function here, knowing this is 4 minus x, I know that value there is 4, I know that value there is 0. So we don't want the x equals 0, that would be that one there. P is going to be given from the curve, I can then say, by x equals 2.4. Not a solution. Just to make it clear to the examiner that I actually understand that x equals 2.4 is my answer. Then part B says region R1 and R2, we'll have a look at those in a second when I scroll back up, but R1 is going to be equal to R2 given the situation that this is the line x equals k here. What we're saying is, let's get rid of some of those bits there, that this area here is going to be equal to this area here. Or just imagine, for example, that that area worked out to be 1.5, then this area would have to work out to be minus 1.5 because it's below the axis. So if I integrated it, I'd get minus 1.5. But this is going to give me the key to solving this question then. If I integrate the function between 0 and k, the 1.5 and the minus 1.5 will cancel, or whatever those areas are will cancel. So if I integrate my function between 0 and k, I'll get 0. So let's tell the examiner that I've told you, but let's now tell the examiner what we're going to do here. So we can say part B, if R1 equals R2, then the integral between 0 and k of my function, say fx dx, will equal to 0. So the area, which equals the integral between 0 and k of, let's do it with the multiplied out version, ax to the 3 over 2 minus 2x to the 5 over 2, that is going to work out to be equal to 0. So just do a little bit of work in actually doing that. Integrating, add 1 onto the power, divide by the new power. I'll do it slowly. So divide by the new power, minus exactly the same thing again. Add 1 onto the power, makes 7 over 2. Divide by the new power, so divided by 7 over 2. If I put in the values of k and 0 into that, that's going to work out to be equal to 0. Tidying up that, I'm going to get 16x, 16x to the 5 over 2 over 5 minus 4x, goodness sake, to the 7 over 2 all over 7, all between k and 0 is going to equal to 0. So in other words, 16k to the 5 over 2 over 5 minus 4k to the 7 over 2 over 7 is going to be equal to 0 because the two values work out to be equal to 0. So we're just solving this equation now. So 16k to the 5 over 2 all over 5 equals 4k to the 7 over 2 all over 7. Cross multiplying that, I'm going to get, you can do this whichever way you want now. So k 5 over 2 equals, what's that going to be, 20k to the 7 over 2. Take them all onto one side and take out a factor. So I'll get 112k 5 over 2 minus 20k 7 over 2 equals 0. I'm going to take k to the 5 over 2 out as a factor, which leaves me 112 minus 20k is equal to 0. So I'm either going to get k equals 0 or k equals to 112 over 20, and that will tidy up to 28 over 5. Let's just go back and see, what does it says? Well, k obviously can't be equal to 0, otherwise it wouldn't work. So k is constant. From our diagram, we can say k then works out to be equal to 28 over 5. Okay, not too bad a question there. Hopefully that all makes sense to everybody.